How can we take that application we built in the previous lab and make its front end highly available? That's the focus of our next lab.
In this demo, we'll take an existing ASP.NET MVC application and make it both resilient against the failure of a single web server and scalable to support changes in load, using Google's load balancer. We've already created the Windows virtual machines that we'll need to build our application. We've got a Windows server running Internet Information Services and ASP.NET. This will be our web server. And a separate Microsoft SQL Server machine that's hosting the application's database. There are several moving parts to configure before we get to the load balancer, so let's get started. First, we'll take our web server and stop it, and then delete it, keeping the custom disk. You can see that my www machine, which is our web server, has already been stopped. When we click on the delete button, we're going to keep the disk but remove the machine. Okay, now that machine's been deleted. If we take a look, because we decided to keep the disk, we've still got our disk available. Now we can go to the Images feature. We're going to create a new image based on that disk. I'm going to give the image a good name. I'll call my image www image. The source for the image is going to be a disk. And the source disk that we're going to use is the www image. I'll click on Create and the image will be created. We'll pause the video for a few seconds while that happens. Okay, so now our image is ready. You can think of this image as being like a gold master for our application. We can use the image to create new disks which have our software pre-installed. Now we've got our image, we'll create an instance template. This provides a specification for creating virtual machine instances. If we click on the Create Instance Template button, then we get to fill out a form. It's very similar to the VM instances form that we may already have seen. So I'm going to call my instance template www instance template. I'm going to select 1 CPU and 3.75 gigs of memory, which will be fine for this particular demo. For a real-world application, we can pick exactly the right shape of virtual machine that will fit our needs. For the boot disk, we need to change this to make use of the custom image that we just created. So I'll select custom images in the console and then the www image that we created previously. You'll notice how it automatically populates the correct size of disk. Click Select and we're done. Click on Create and now we're all good to go. Now that our instance template is ready, we'll make use of this to create a Compute Engine managed instance group. A managed instance group can be used to automatically spin up a set of machines based on an instance template group. So I'll change the name to www instance group. In terms of the location, for high availability, we'll select multi-zone. And because our SQL server is in the US Central 1 region, we'll select that region for our managed instance group as well. We need to determine the instance template. We'll use the www instance template that we previously created. We're also going to make use of the autoscaler. The autoscaler will automatically adjust the number of machines in the managed instance group based on some metrics that we can specify. We'll use the default metric of CPU usage at 60%. And now in terms of the number of instances, For high availability, we should really have a minimum of 3 instances. These will be distributed across 3 different zones within our region. But we'll just use 1 as our minimum number of instances, but we'll select 3 as the maximum number of instances. That will do for now. Let's create that managed instance group. You'll notice how the managed instance group will automatically provision the minimum number of instances that we specified in our pool. As we said that we wanted between 1 and 3 instances, the managed instance group will be directed by the autoscaler to create 1 instance. Okay, now our managed instance group is up and running. We can drill down into the managed instance group and you can see that it has 1 member. Now we can create our load balancer. We find that within the network section of the products and services menu. So down to networking and then choose load balancing. So to create a load balancer, we'll click on the Create Load Balancer button. You'll notice how there are several available load balancers. Typically, for a web application, you'll make use of the HTTP/HTTPS option. Just one word of caution: if you're using Windows authentication with ASP.NET MVC, then at the time of this presentation, it doesn't work with the HTTP and HTTP load balancer, and you should select the TCP load balancing option instead. Our application isn't using Windows authentication, so I've selected the HTTP load balancer. This provides a global IP address that will direct traffic to a set of machines in a managed instance group that can respond to HTTP requests. In our case, our IIS web servers running our ASP.NET MVC web application. We just need to enter a name for our load balancer. I've selected www load balancer. We need to complete several pieces of configuration. First, we'll choose the back end. The back end can be connected up to our managed instance group. So to do this, we'll choose Backend Services, create a backend service, and then enter the name for the backend service. I'll call this www backend service. We can then plug backends into the backend service. You'll notice how this is done with an instance group. So here's our www instance group. Now we're done with our backend configuration. If we want to support global clients, then we could have multiple managed instance groups in multiple regions. I'm also going to create a health check. The health check allows us to determine that our machines are capable of serving traffic. So I'm going to call this www health check. I'm going to just do this using HTTP requests onto port 80 and simply request the home page. If the home page responds, then our application is healthy. We could also create more sophisticated health checks which had a specific page that determined that every aspect of our application was working, but this will do for now. Click on Create and our backend is configured. Next, we can review the other aspects of the HTTP load balancer. Firstly, the host and path rules. We could use this to direct traffic to different backend services or other resources in order to service our traffic. So for example, we could have static traffic hosted in Google Cloud Storage. We don't need that for our application. so we can just use the default configuration where all the traffic is directed to our backend service. Finally, we have our front-end configuration. We're just directing traffic over HTTP, and this has already been completed. Now if we click on the Create button, our load balancer will be constructed. We'll just have to wait a couple of minutes for that load balancer to become available, and once it is, our application will be ready to go. Okay, now we're back. So you'll notice that a global IP address has been created. We'll just select this and try it in a new browser tab. Here's our application. If we enter the URL for our custom page, here it is. So that's great. That works really well. So that completes our demo. We've harnessed a set of Google Cloud Platform resources: Compute Engine images, instance templates, managed instance groups, and the networking load balancer to create a scalable, highly available